Good morning, students. Today we are going to learn how to write chemical formulae of various compounds. Now, students, keep in mind that in order to write chemical formulas, you have to learn names and symbols of all the ions present on page number 37 in table 3.6. Before proceeding, let's understand what does a symbol of an ion represent. In case of magnesium ion, Mg represents the symbol of the element, the sign positive represents the charge, and the number that is present with the charge represents the valency. That means symbol is Mg and valency is 2. Similarly, for chloride ion, Cl represents the symbol, minus represents the charge, and 1 represents the valency. Students, the knowledge about symbol and valency comes in handy for writing the chemical formulas. So, let's take an example. What will be the chemical formula of magnesium oxide? So, first of all, write down the symbols of magnesium ions and oxide ion. That means Mg plus 2 and O minus 2. Now, students, note that we always have to write down the symbol of cation first and anion afterward. That means the positive ions, they will be written first and negative ions will be written afterwards, as in this example. Now, write the symbol and valency of ions separately. That means symbol of magnesium Mg and its valency, that was 2, below the magnesium ion. Similarly, symbol of oxide, that was O, and its valency, that was 2, beneath the oxide ion. That means in the same manner. Now, students, next step is that we have to make sure that the valencies, they should be in the simplest ratio. In this case, the valency of magnesium is 2 and oxide is again 2, and these two are not in the simplest ratios, and the simplest ratios will be when we will divide these two with 2. That means first of all we have to convert them into simplest ratios, that will be 1:1. After converting them into simplest ratios, now we have to write down the formula. For that, write down the symbol of Mg first, and then we have to write down the valency of oxygen. That means we will cross multiply, and after cross multiplying we will write the simplest valency of oxygen, that was 1, that has to be written as subscript, that means at the foot of Mg, and we will then write the symbol of oxygen without leaving the gap. That means we have to continue, write down the symbol of oxygen, and then cross multiplying, therefore we will write the valency of magnesium, that after comes after simplification, that was 1. We have to write it as subscript. That means our formula will be Mg1O1. Now, students, we don't have to write 1, therefore we can simply write it as MgO. So this is the chemical formula of magnesium oxide. Once again I am repeating, you always have to write the cation first and anion afterwards. Write down the symbol and valency separately, then write down the valencies into the simplest ratios, and after converting them into simplest ratios, cross multiply the valencies. That means valency of oxygen will be written as a subscript of Mg, and the valency of Mg will be written as subscript of oxygen, the simplified valencies. And after cross multiplying, write down the chemical formula of the compound. Let's take another example. What will be the chemical formula of zinc chloride? Write down the symbol of zinc ion and the symbol of chloride ion. For zinc, symbol will be Zn, valency will be 2, and for chloride, symbol will be Cl and valency will be 1. So after writing symbols and valencies separate, we can see that here valencies are already in the simplest ratios, therefore we can directly cross multiply them and we will write down the formula. That means formula will be Zn, and in the feet of the Zn, we will write 1 as a subscript, and then Cl, and at the foot of Cl we will write 2 as the subscript. That means our formula will be ZnCl2, because we don't have to write 1, so our formula will be ZnCl2. Next we have an example of aluminium sulfate, in which the sulfate is a polyatomic ion. Now students, note that the basic rules for writing chemical formulas involving polyatomic ions are same, with just a slight difference. So first of all, we will again write the cation, then anion, then we will split symbol and valencies. In case of aluminium, the symbol will be Al and the valency will be 3. And in case of sulfate, that is your polyatomic ion, students, note that only that number which is present with the charge, that is called valency, whereas the remaining entire entity is called symbol, which means in case of sulfate, 2 will be the valency, whereas SO4, the whole entity will be the symbol. So that means for writing the symbol of sulfate, we will write SO4, and for writing the valency we will write only 2. Now we already see that 3:2 is the simplest ratio, therefore cross multiplying we will get that Al2 and SO4 thrice. Now students, note that this entire entity, because it is a polyatomic ion, this entire entity has to be written in brackets before writing the valency of aluminium. This is the only change that takes place in polyatomic ions. Rest is similar to the simple ions. Note down number 1. First of all, make sure that you are writing the proper symbol of the polyatomic ion. And number 2, while cross multiplying, that means while writing the chemical formulas, the symbols of the polyatomic ions, they are written in bracket before writing the valency. That means the formula for aluminium sulfate is Al2 bracket SO4 bracket close 3.